motor and the engine. We don't usually charge hybrid electric vehicle because the process of regenerative braking charges the battery in the hybrid electric vehicle. But in the case of a battery electric vehicle and plug-in hybrid electric vehicle, we will charge the battery. So basically, charging is done in two types, that is AC charging and then DC charging. So in AC charging, we know the left side portion of the electric vehicle. We don't directly charge the battery in the case of a AC charging battery. What we will done? We will first charge the onboard charger. Now all the vehicle have this onboard charger. So what is its function? Its function is to convert the AC to DC. Then onboard charger will charge the battery. We can see in this diagram. In the case of an AC charging, we will first charge the onboard charger. Then the onboard charger will charge the battery by supplying DC current. Some disadvantages of AC charging is that it is a limited power and also they are slow charging. But in the case of a DC charging usually all are fast charging. We will directly charge the battery by powering it with a DC source. And nowadays, DC charging stations are integrated with the renewable sources like solar and wind energy. What is its use? That we know renewable energy sources produce DC other than AC. So directly connecting it with the renewable sources, we can provide a power source for the DC charging stations. Nowadays, large number of investment is shared among the for the DC charging stations. Advantage of DC charging stations are they are usually fast charging and also they provide a large power rating. Okay. So next, we are going to just look upon the typical battery specification for a different EV segments. So first is the 2W. 2W means two-wheeler vehicles. In two-wheeler segments, generally the battery capacity will comes in the range of 1.2 kilowatt hour to 3.3 kilowatt hour. Also the battery voltage rate from 48 to 72 volt. What is the change in the voltage is that generally nominal voltage is 48 volt, but in the case of a full charging, it will the voltage will rate up to 52 or 60 something. Generally we saying that the battery capacity is up to 3.3, but in some two-wheeler like Ola S1 Pro, they were using 4 kilowatt hour, but in Ola S1 they are only using 3 kilowatt hour of battery capacity. Either 450X will use a battery of 3.7 kilowatt hour. Then coming to a three-wheeler, the battery capacity will ranges from 3.6 to 8 kilowatt hour, and also the voltage changes from 48 to 60 volt. Generally saying some of the EV three-wheeler EV like 𝐻𝐼𝐴𝐚, the brand 𝐻𝐼𝐴𝐚, the capacity is like 10 kilowatt hour. So coming to the different brand, the battery capacity ranges will changes. So come to the e-cars. E-cars means the first generation electric EV, four-wheeler EVs. In four-wheeler EVs, first generation, like basic ones, the battery capacities are comparatively low compared to nowadays. And also the voltage rating. The battery capacity is rated up to 21 kilowatt hour. The voltage rated also below 72 or something. Okay. In nowadays, four-wheeler electric vehicle, the voltage, battery capacity ranges from 30 to 80 kilowatt hour. Okay. Then also the battery voltage changes from 350 to up to 500. And some of the vehicles also have a 800 voltage. Okay. Some of the four-wheeler like Tata Nexon, it have a battery capacity of 14.5 kilowatt hour, and the Tesla Model S. We are all familiar with the Tesla Model S, right? So in Tesla Model S, the battery capacity is 98 kilowatt hour, much higher than the other brand. Okay. In Hyundai, some of the Hyundai Kona model, the battery capacity ranges from battery capacity is somewhat like 64 kilowatt hour. Okay. So the come to different brand, the battery capacity will changes. Coming to levels of charging. So there are mainly 3 levels of charging. Level 1 is basically home charging. Then level 2, it also semi home charging, and some of the public sector we can see the level 2 type charging. And level 3 is a DC charging stations. Nowadays we are seeing in publics, right? Okay. Then what are the specifications of level 1 charging? In level 1 charging refers to the basic method of charging electric vehicle. Its power ranges only up to 3.5 kilowatt. Generally, it is the slowest among the 3 levels of charging. That's the level 1 charging. Generally, it is suitable for overnight charging at home. To facilitate level 1 charging, EV owners use only the standard charging cable at the homes with their vehicle. Then coming to level 2 charging, they are more advanced than level 1 charging. They saying level 1 and level 2, they are both AC charging. In level 2, the power ranges of charging from 3 kilowatt to 22 kilowatt. So to facilitate level 2 charging in houses, we have to install level 2 charging stations in home. So for facilitate level 2 charging in our own house, we have to install separate level 2 charging stations. Okay. For a level 1, we have to just plug our 3-pin socket to the plug. But in the case of a level 2 charging, we have to install or we have to buy with our electric vehicle the charging station for level 2. Okay. Then coming to level 3.
Jibin, you are muted.
Hello, am I audible now?
Yes, you are audible.
Wait, I will. Sorry for inconvenience. We'll start from. Up to which slide have you heard? Can anyone say? Hello? Am I audible now?
Yes, sir. Yes, sir. Third level charging.
Up to level 2 is over.
So now we are saying about level 3. In case of level 3, it is the most fastest and most powerful levels of charging. The output ranges of the level 3 charging is from 22 kilowatt up to 400 kilowatt. So unlike level 1 and level 2 charging, level 3 charging needs a separate DC power station. So it is suited for long distance travel and situations where quick charging is essential. Okay. I think you are all familiar with the 3 types of levels of charging, right? Then coming to EVSC. So EVSC means electric vehicle supply equipment. It is nothing but the electric vehicle charging station. But as I said before, in the case of a AC charging, it won't charges the battery directly. It will charges through the onboard charger. But in the case of a DC charging, it will charges directly. What EVSC control system doing is that its functions, right, authentication and authorization for charging, and information recording and exchange for network management, also data privacy and security. Actually, what EVSC is working is that when we are plugging or charging cable into the EV with the EVSC module, first the control module in the EVSC analyze the connector on the plug to make sure it is properly connected. So after it makes sure that the connector is properly connected, then the car is ready to charge. So then the EVSC will blink a green light. So then the EV is ready for charging. So also when if the main relay powers the cable connected to the car, and also if the current rating is higher than the rated current, it will automatically shut off. So next we will familiarize some of the components of EVSC. These are the different components of EVSC. First is the power supply unit. What its function is that it will regulate the voltage and current to provide a controlled and safe charging process. So what its function is that it will control the voltage and current to charge an EV. Then the connector and cables. What connector is doing that it will act as an interface between EV and EVSC. So the cable will help to connect the power supply to the connector, allowing the electricity transfer to the from EVSC to vehicle. Then next is the control and communication module. What the control module will do is that a control unit manages the charging process, including starting and stopping of the flow of the electricity. It also monitor the charging status, also ensure the safety protocols are following. Then the communication module. The communication module will facilitate communication between EVSC and electric vehicle. Okay. Then the fourth is the ground fault protections. These are all the components inside the EVSC. The ground fault protection mechanism, it will protect our EVSC from the further from the faulty. If the connection is not properly connected, it will protect the vehicle and EVSC from the shock occurring. Then the metering system. The meter system measures the amount of electricity consumed during the charging process. Then the user interface. The user interface, what it is do is that it provides a way for EV owners to interact with the charging stations. They will interact with the EV owners. EV, the electric vehicle supply system, it will interact with the electric vehicle owner through the user interface system, because they are sharing, transmitting data between the electric vehicle and the EVSC. So last, the authentication and the payment system. So they are usually seen in the public EVSC. In public charging system, the authentication and payment system maybe they will integrate it to the control system to the charging station and facilitate payment for the electricity consumed. Okay, then we are going to the types of charging station. So first is the fixed charging station. As I said before, there are 4 types of charging station. First one is the fixed charging station. So generally fixed charging stations are 2 types: AC charging system and DC charging system. In AC charging system, as I said before, we will first charge the onboard charger. Then the onboard charger will convert the AC to the DC, and it will transit to the battery. Okay. Then next is the DC charging system. DC charging system, they are fast charging system. There are mostly seen in publics. We are all familiar, right? So in DC charging, the DC power wires directly connected to the BMS and battery. Okay. So in fixed charge, generally we can say that there are four modes of operations. Mode 1, mode 2, mode 3, mode 4. So mode 1, mode 2, mode 3 and AC charging. In mode 1, there is only a 3-pin socket. There is no communication system between our EV, electric vehicle, and the charging station. Just connecting it with the 3-pin socket. But in mode 2, it is also a 3-pin connection, but there are the communication pin. It is called as control pilot. It will act as a communication between the EV, electric vehicle, and the electric vehicle charging center. Then mode 3. Mode 3, there is we are using 3-phase AC, and also there is a communication system. While coming to mode 4, mode 4 is a DC charging system. In mode 4 charging system, there is the fast charging and also the communication between EVSC and EV. So next charging station is the mobile charging stations. So currently nowadays in India, I think mobile charging stations are not developed yet. It will develop soon. The mobile charging is a portable unit designed to provide charging solutions for an electric car in locations where the fixed charging stations are not available, or in locations where these fixed charging stations are non-existent. So what is a mobile station is that it's a portable it is a vehicle carrying a large greater power, right? Greater number of batteries. So these stations are characterized by their portability, allowing them to be swiftly deployed to meet temporary charging demands. So especially during events in remote areas. So we know in remote areas the charging stations are not available. So we have to charge our EV for a certain distance to travel to other charging centers. So at that time we will call the mobile charging stations to charge our EV. And they are also characterized with the different types of charging connectors like CADMO, CCS, and type 1 and type 2. We will discuss later about that. Okay, so that is about mobile charging. So next is the wireless charging. So nowadays we are familiar with wireless charging. So wireless charger works in the principle of mutual induction. We all know about the mutual induction, right? So in this wireless charging, there are two coils. One coil will in the charging station, and the other coil will be in the EV, electric vehicle. So while powering the electric vehicle, while powering the coil in the station with the AC, it will transmitted to the AC power is transmitted to the coil in the electric vehicle by the principle of mutual induction. And with the use of onboard charger, it will convert that AC to DC and then charges the battery. So in figure, it is a demonstration for the wireless charging. Nowadays, these wireless charging stations are mostly available in parking areas. While parking, the vehicle automatically align with the coil, and it will automatically charges, and we have to pay certain amount for the wireless charging. Also, wireless chargings are enabled in some road highways. Now in India, it is not established yet. In foreign countries, they are in some places they are established wireless charging facilities in road highways. What they are doing is that, as I said before, a coil is inserted in the road while the EV is moving. The charge will induced to the EV by principle of mutual induction. So we can see in the slide just a demonstration for the wireless charging in the road areas. Okay, they are separated, noted down. The road with the wireless charging are separately noted, as we can see in this picture, and we have to pay certain amount for moving our vehicle through these types of roads. So we have discussed about three types of charging stations yet now. The first one is a fixed charging, then second is a mobile charging, then third is the wireless charging stations. Then now we are discussing about battery swapping stations. So battery swapping stations, we are exchanging our fully discharged battery with fully charged battery. So in this figure, we can see the just demonstration of the battery swapping station. Generally saying, there are two types of battery swapping station, we can say. The first one is a manual type. In manual, the battery swapping station is a standalone device. So in which batteries are placed and removed manually from individual source. In this picture, it is a manual type of battery swapping stations. We have to do it with our hands, and also they are used for only two-wheeler and three-wheeler battery, because coming to four-wheeler, the battery will weight high, so we cannot just exchange it with our hand. So next type of battery swapping station is the automatic battery swapping stations. So in this automatic battery swapping station, a robotic arm is used, and these types of swapping stations with the battery process being semi or fully automatically, and the robotic swapping is used for four-wheelers. As I said before, the four-wheeler battery weight high, so we cannot replace it with hand. Also it is having high voltage, so we will use robotic arm to swap the four-wheeler. And also EVS applications, we are using this automatic battery swapping station. Okay, so we can just discuss some of the advantages and disadvantages, challenges of the battery swapping. So what are the advantages of battery swapping? As we all know, one of the disadvantages of our electric vehicle is that the high charging time. So by implementing a battery swapping station, we can charge our EV in minutes. So the charging time will comparatively reduce. So other advantages are reduction in upfront cost of EV, as battery ownership is replaced by a battery leasing, and increased predictability of battery life due to controlled charging conditions. So in battery swapping stations, they are controllably charging our battery. So battery life can be increased. Also, batteries can be charged away from swapping point, allowing more freedom in setting up swap facilities. So they are in battery swapping station, they are with the high advantages, but also they are with some of disadvantages. We can just discuss the challenges of battery swapping. So one of the major challenges facing in the battery swapping is the lack of standardization among EV batteries. We know different companies having different dimension of batteries and their weights are different. So we cannot swap. So first we have to need standardization of EV batteries for implementing the battery swapping stations. Also, greater number of batteries needed to power same number of EVs. Also, higher GST on separate battery than the battery sold with the EV. The taxes are high for a battery without a EV. We have to, if we have to buy a separate battery from a shop, we have to pay extra tax for the. Okay, so these are the challenges and advantages of battery swapping. So now we are going to look up to some of the different types of charging connectors now we are using in worldwide. So as I said before, there are two types of charging connectors, AC charging connectors and also the DC charging connectors. So while look up to the AC charging connectors, first is the type 1, or we call it as 𝐲𝐶772 connector because it's standard. It's standardized. It is standardized. So its standard is called the 𝐲𝐶772. So it is widely used in USA, and a total number of pins are 5. Also, they are coming with the communication. As I said before, the communication pin are control pilot pin. So the typical power rating is between 3.3 kilowatt to 7 kilowatt. So we can see the pin diagram of the 𝐲𝐶772. We can see L1N, that is phase and neutral. Then PE, it is called protective earth, protection of electric vehicle from earthing. And PP and CP, they are communication pin. PP called proximity pilot and CP called control pilot. What proximity pilot is that it will ensure the connection between connector and the EV. So we have to ensure whether the charging connector is properly connected with our EV. So it will facilitate the connection between the EV and the EV charging connector. If the connection is not properly done, then the PP will give a signal to the charging station and the charging will not done. And CP is the control pilot. It will act as a communication network between charging station and our electric vehicle. How much charge is taken from the charging station. Also, if the current rating is higher than the rated current rating, it will cut off the power supply to the electric vehicle. So these are the functions of the control pilot pin. So next is the type 2. In type 1, it is single phase. In type 2, it is 3 phase. So its standard is the IEC 62196. So in this connector, there are total number of pins are 7, and also it is coming with the communication network. The pin is also called a control pilot. The power rated is from 3.3 kilowatt to 22 kilowatt. So since it is 3 phase, it have a high power rated than the type 1. Okay, so we can in figure we can see the pin diagram of the type 2 connector. As I said before, L1, L2, L3, these are 3 phases, and N neutral. Then PE is the protective earth for the protection from the earthing, and CP is the control pilot, and PP is the proximity pilot. So these two are the generally using AC charging connectors in electric vehicle. Okay, so next is the IEC 60309 charging connectors. They are mostly used in e-rickshaws, not widely used in for other vehicle, because there is no communication between the there is no pin for communication between a charging station and our electric vehicle. So it is not advisably using because of the lack of the communication network. It consists of only 3 pins. just a protective earth and a single phase and a neutral. Generally, power rating is only up to 3.3 kilowatt. So these 3 pins are widely used as the AC charging connectors. Okay. So next is the DC charging connectors. Also, DC charging connectors are 3 types. First is the CCS. Its full form is combined charging system because it is combined with the type 1 and type 2. CCS are standard, generally used in Europe and most widely and used standard globally. Okay, it consists of there are 2 types of CCS. We will say combo 1 and combo 2. Combo 1 are similar with the type 1. The additional 2 pins for the DC power supply. Then combo 2 is similar with the type 2. As I said before, the difference is that it will consist of 2 additional pins for DC power supply. So they are using power line communication like a control pilot for the communication between or charger and a charging connector. Or charging station and or electric vehicle. Typically, the power rating is up to 350 kilowatt for a combined charging system. These 3 DC charging connectors are with high power. It means that they are using for fast charging. Okay. So next is the 𝐲𝐴𝐵. 𝐲𝐴𝐵 is the Japan word. So in Japan it is called its meaning is that charge de move. Its general meaning is that charge for moving. It is the meaning of the that is a actual meaning of the 𝐲𝐴𝐵. So it is a standard used in Japan. Okay, it totally consists of 10 pin. Other than CCS, here the communication network is CAN module, control area network module, used for the communication between charging station and our vehicle. The power rating up to 400 kilowatt. Since it is a DC charging connector, it is of with the fast charging. The pin diagram we can see there. So we can see the ground wire for protecting from earthing. Then 2 large pin DC power supply, DC plus and DC minus. Then 2 pins for charge starting and stopping for charging done and charge stopping. And also they will enable and disable. Enable and disable is similar with the proximity pilot. It will ensure that the charger is properly connected with our electric vehicle. After that, it will enable the charger, or it will, if the connection is not properly done, it will disable. Okay. Then CAN L and CAN H, CAN high and CAN low. Generally, the CAN communication will come with 2 lines, that is CAN high and CAN low. Okay, that's all about 𝐲𝐴𝐵. Then the next charging connector is China GB-T. It is a standard used in Chinese, and it is also adopted by some of Indian EV manufacturers. Okay, so GB-T, its meaning is that a national standard recommended. It is the proper meaning of the GB-T. It consists of total number of pin is 9. Also, the communication network is a CAN. Typical power rating is only up to 180 kilowatt. Okay, then coming to the pin diagram, as I said before, the DC plus and DC minus for DC fast charging. Then CAN H and CAN L, control area network high, control area network low for the communication purpose. Then proximity pilot PP. PP is the pin used for the connection for proper connection between the charger and the electric vehicle. then auxiliary power plus and auxiliary power minus. These are the auxiliary DC power. They will supply only up to 600 watt. For just delivering 600 watt of power supply, we are using auxiliary power plus and auxiliary power minus. Then the PE, protective earth. So these are the main 3 electric DC charging connectors widely used in worldwide. So that's about our today's section. If you have any doubts, you can ask now. Hello, am I audible?
Yes.
Yes.
Sir, this is Prasad Kulkarni from KIT College.
Okay.
Sir, can you just elaborate the different voltage levels for batteries presently available?
As I mentioned in the PPT, for a two-wheeler, the voltage level ranges from 48 to 72 volt. For a three-wheeler, it will changes from 48 to also some of the three-wheeler having 72 volt up to. But in the case of four-wheeler, they are using high voltages, generally from 350 volt to some of the EVs are nowadays using 800 volt out of battery.
Yes, sir. Thank you, sir.
Okay.
Good evening, sir.
Yes.
Sir, could you please reply the chat box?
We cannot share this PPT because it is our confidential to our company. So you have to ask for the other members of the company, like directly ask to our ISIEINDIA, or you can just register for any other courses. So you can get this PPT.
Concern the team for the PPTs.
Yeah, good evening, team. This is Vinod. Actually, can you please explain about optocoupler circuit in the charger?
What is that?
That the optocoupler circuit to secure this
Optocoupler circuit for in charging.
Yes.
So optocoupler circuits are used in chargers. They are basically saying that they are power electronics circuit for converting this AC to DC. We are using this optocoupler circuit. Okay.
Okay. This session, recorded session, you can share later on.
Yes, it is sharing, right?
Thank you.
Sir, can you hear me, sir? Yes. Sir, can you elaborate on regenerative braking system? Because regenerative braking system also charges the electronic vehicles, no, sir. So under what category does it come? Like under AC or DC, or it has other separate categories? In case of regenerative braking, so do you know something about the what you know about the about this regenerative braking? So when you give brakes, the electric vehicle charges automatically, sir. Charges automatically. So what is happening is that we know we can if we rotate the shaft of our motor, it will act as generator, right? Yes, sir. So while braking, the wheel will rotate and it will rotate the shaft of the motor. So then it will produce an electricity in the form of AC. So first the AC will goes to the inverter, or we can say the power converter device. Okay, then in that the AC will convert it to DC and it will stores in the battery. Okay, nothing but just the motor will act as a generator, and we know if the for a generator we will if we rotate the shaft, it will produce electricity in the form of AC. Okay, so the AC will transmit to the power converter device, and the in power converter device the AC is converted to DC and stores in the battery.
Sir,
Okay.
but in non-electrical vehicles like in scooty, we have a choke. So when you are out of petrol, you give the choke button, and for some distance, the vehicle will move. So similarly, if you are out of charge in the electronic vehicles, you can use the regenerative braking system, sir.
If you are out of charging, we cannot use that. So otherwise, you have to rotate the vehicle continuously for some times. It is not possible, right? So if you are out of battery, you cannot use a regenerative program for the charging battery.
Then what is the alternative for out of charge capacity, sir? So like a non-electrical vehicles, you have choke now, sir. So
what the alternative purpose is that are you aware that in a non-electric vehicle the 12-volt lead acid battery is available, right, for lightning and for other infotainment system. Okay, so for charging that battery we are using the alternator power.
Okay, sir. Okay, sir. Thank you.
Okay.
But this is Vinod speaking again. Regarding this regenerative braking, is that the pulses can able to push battery to charge within fraction of second?
As we all know, the time limit is very low, but we will use the boost circuit. Okay, so we will use the boost circuit for charging. If the voltage generator is much low, we will use the boost circuit for generating high charge. Or also we will use the capacitors for charging. But because the regenerative braking is done in fraction of second and also in some cases it is difficult for charging a battery for suddenly, right? So we will use a capacitor for that charging suddenly purposes.
First it will stored in capacitor, then it will be consumed
to the battery.
Okay, thank you. Okay. This will be loaded in BMS or it will be done it in motor controller unit?
What, sir?
It will be happened in MCU, motor controller unit, or through BMS, where the MOSFETs are there to do this.
Conversion purposes take place in MCU or the power converter system.
Okay.
Not in BMS.
Okay, that booster circuit also there in.
It is also separated circuit, not BMS, not inside the BMS. It will also external circuit.
Okay, that is not integrated in MCU as well.
Yes, no.
Okay.
Sir?
Yes.
Sir, in battery management system, you have that controlling unit, battery management system. You collect the data like state of health, state of charge, and other power consumption unit, and all the other parameters, which is used to determine the life of the battery now, sir. So where all this data will be stored in the EV vehicle,
sir? Data will be stored in the majority saying some of the data will store in the BMS. If the other data for the related to the motors and other data, it will store in the control system. And while collecting the data, we will connect with the control system. Then this generally saying MCU. We will connect with the MCU, and then MCU take the data from the BMS and will give it to us. Generally, data is stored in BMS.
Okay, sir. In future, can we see the alternative for lithium-ion batteries, or EV vehicles will use only lithium-ion batteries, sir?
What is the reason for we are using lithium battery, right?
Yes, sir. So in the future,
as you know, other batteries in previous years, in 90s, the first EVs is installed. EVs are using lead acid battery. So what is the reason that we are not lead acid is that it does not have the energy density, like energy weight ratio, like lithium. If you are having same capacity of lithium and lead acid will have high weight than the lithium. So we cannot use the that's why we are not using lead acid right now.
thank you, sir. Okay.
So can you please elaborate the CAN system used into the EV charging structure?
If you are going to elaborate, it will take more sections, right? Because
just
communication system is very vast. If you are that much eager to learn that, you have to pick some of our courses related with the battery management system. Okay, or generally saying CAN control is a communication system with two line communication. That is, there are two lines for the communication. That is CAN H and CAN L, CAN high and CAN low. The data is transmitted in a signal with the difference in the voltages. Okay, if the CAN high and CAN low voltages are in based on the difference, the data is transmitted. If you want elaborate section, you can try up to some of our courses. Okay.
Yes, thank you. So that voltage difference will be standardized, or else it might be anything.
No. It is generally the CAN high only goes up to 5 voltage, right? So the voltage will based on the difference in voltage, the data is transmitted.
Okay, sir. Thank you.
Sir, regarding this AAS 156, sir, charger, what are the controls we need to take care?
Can you repeat, sir, once more?
Actually, as per our Indian government norms, AIS 156 is a standard, right, for the EV charging as well.
Yes.
In that, what are the measures we need to take care for chargers alone?
You are asking what are the communication system used in A556 charger, right?
No. AIS 156 is a standard which we need to follow for EV vehicles. Regulation, homologation standard from Indian government, right? In
yes,
that, to manufacturing the charger, what are the control measures like overcharge protection, over voltage protection, like that? We have some specific requirements given by our government regulations body. Na? Can you please give me, you have idea about it?
Currently, I don't know much about the detail about that standard. Sorry, sir.
Fine, no issue. Thank you.
As per the Bureau of India, it is given like what are the efficient high voltage rating, or what are the current rating components are there. Like for a 4-wheeler, they're having a different type of cables. Or when we're talking about 2-wheelers, so like we having onboard chargers. So they're having a different types of cable for the like IOC certified and the standards.
Thank you.
If anyone having questions, you can ask. Thank you for watching the webinar. I hope you will find its best. Here is our short video for ISI India courses. You can watch now.
Thank you very much for such elaborate.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, globally valid certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
If you have any query regarding our courses, you can scan this QR code and your request will be given to us and our executive will call you by tomorrow. Okay? Thank you for watching webinar. You can leave now.
Sir, when will you get the certificate, sir? Are you having any certificates for this course?
Sorry, you are not audible.
So, are we having any certificates for this course?
Can you drop your query in chat box?
Can you please share this recorded session as well?
Yes, we will share the link of our channel, okay, in mail.
Thank you.
You
Thanks.
can watch.
Hello there.
Yes.
Hello there. Sir, if I want to train in ISIEINDIA, what is the process?
The QR code which is a display on the screen, you can scan this QR code and fill your details. Okay.
Okay, sir. Thank you.
If anyone having the regarding courses, you can scan this QR code.